Being tired of the increasing cost of his electric bill, John started to seek ways to reduce it. One day, while reading the newspaper, John saw advertisements from high-quality electric efficiency companies which, upon buying their products and improvement services, were guaranteeing fuel reduction for the entire house by 40%, 35%, and 25%. John's initial plan was only to reduce the bill by as much as he could. However, after seeing the ads, he had a brilliant idea. He could do all the changes the three companies were proposing to eliminate the use of fuel completely. He could pay the hefty fees to the three companies once. And after this, his electric bill would reduce to almost nothing as the required fuel would have been reduced to nothing. And so he did. However, 1 month after the final work was completed, he almost had a heart attack. The electric bill was indeed reduced, but it was only reduced by about 70%. The bill was not close to nothing. He considered himself cheated and accused the companies of false advertisement and factual fraud. He thus filed a lawsuit to recover the fees he had paid to the companies. Your Honor, argued in front of the judge, together the three companies promised a 100% reduction of fuel, since it is clear to anyone that the sum of 40%, 35%, and 25% add to 100%. Pause the video here to think about the discrepancy discovered by John. Decide the strength of his argument and his chances to win. After you have drawn your conclusion, continue the video to see the answer. John will lose his case against the companies. His argument is based on a flawed understanding of what fuel economy really means. Each improvement results to a multiplicative factor, not an additive factor. This statement needs some explanation, so let me provide it. Imagine that, before the improvements, the electric company charges him for 10,000 kilowatt-hours. After the first company makes the improvements, he will save 40% of fuel. In other words, if this were the only change, he would save 4,000 kilowatt-hours and pay for 6,000 kilowatt-hours. After the second company makes the improvements, he will save 35% of fuel. But this 35% is not on the 10,000 kilowatt-hours. It is on the 6,000 kilowatt-hours that are used after the first improvement. Therefore, consumption will be reduced by 2,100 kilowatt-hours, and, after the second improvement, he has to pay for 3,900 kilowatt-hours. Similarly, after the third company makes the improvements, he will save another 25% of fuel from the 3,900 kilowatt-hours. Therefore, consumption will be reduced by another 975 kilowatt-hours, and, after all improvements, he still uses 2,925 kilowatt-hours. This is really a serious reduction of fuel. John now uses only 29.25% of what he was using before the improvements. He has achieved 70.75% total fuel economy. However, he still uses fuel, and he cannot reduce the use of fuel to zero. Such a demand violates a fundamental law of physics that forbids creation of energy from nothing. The viewer has already understood why improvements are multiplicative, but let me show it once more in a more formal way. Let's define the improvement factor as the ratio of the fuel required before the improvement over the fuel required after the improvement. The three companies have improvement factors of 1.67, 1.54, and 1.33. The combined improvement factor is 3.42. This means that, after the improvements, for every 100 kilowatt-hours that John was using before the improvements, he uses 29.24 kilowatt-hours. This is the amount computed previously. The small difference is due to the rounding of the improvement factors. We can arrive at the same conclusion using the fuel reduction factor defined as the inverse of the improvement factor. The fuel reduction factor gives the percent of fuel used after the improvements. The three companies have fuel reduction factors of 0.60, 0.65, and 0.75. The combined fuel reduction factor is 0.2925. Hence, given the original 10,000 kilowatt-hours, it demonstrates that 2,925 kilowatt-hours will be used after all improvements. I hope you liked this quick problem on fuel economy. If you did, Please subscribe to my channel to encourage more content like this. Thanks a lot for your support.